Hello, everybody. Good afternoon, good morning, good evening, whatever you are watching this video. How you doing? So check this out. This is part 2 to one of my other videos that I showed you guys previously on chemical reaction types. So today we're going to actually get into how to balance these equation types, okay? So first thing you need to do is check all your elements and see if they are equal on both sides. So I'm going to go ahead and take the first problem that's on that screen, and we're going to go ahead and show you all the steps you need to do to solve these kinds of problems. So let's get into it. Step number 1, I have already placed below all the elements from the reactant side versus the product side. So on my reactant side, I have 2 nitrogens and 2 hydrogens. On my product side, I have 1 nitrogen and 3 hydrogens. Are y'all with me so far? Good. All right, so now you need to figure out which of these elements is not properly balanced. Meaning, if I got 2 on the left, I need to make sure I have 2 on the right. If I got 3 on the left, I need to make sure I have 3 on the right. So in other words, both sides need to make sure that they're equal. Well, based on what I'm looking at, neither side of either of those elements are properly balanced. So I'm going to go ahead and draw a line down the middle, and I'm going to show you that in this case, you need to do what we call finding a common denominator, common multiple. In other words, what do they share in common? So if I look at the 2 on the left and I look at the 1 on the right, I know that if I multiply those two numbers, 2 times 1, I'm going to get 2. That's what they share in common. Usually, you want to multiply those 2 numbers to get the common number, so that when you look to see how I can properly balance this reaction out, it'll be easier to do. So these 2 numbers match up. So I do not need to put a number right here in front of nitrogen. However, on the product side, I know that I have to figure out what number times 1 is going to give me that 2. And it is 2. So guess what I'm going to put right here in front of NH3? I'm going to put a 2 there. So I now have 2 nitrogens. But guess what? You have also changed the number of hydrogens that you see. So when you multiply that coefficient of 2 times that subscript of 3, you now have 6 hydrogens. So guess what? 6 is going to be my common multiple, my common denominator for hydrogen. So I've already completed the product side of my nitrogen and hydrogens, but now I need to go ahead and mosey on over to my hydrogen side. What number times 2 is going to give me the 6 that I need to make sure that they're equal on both sides? And if you said 3, you are correct. So guess what? That 3 is going to go right there in front of hydrogen. And when you multiply 3 times 2, you're going to get the 6 total hydrogens that you need. Now, I know there's a lot of scribble scrap on the screen, but let me go ahead and show you once more how you can check yourself. You can go back and look at everything and make sure that every element is balanced. So here's what I'm going to do down below. I'm going to show you that on my left-hand side, I've got 2 nitrogens. That subscript of 2 says I have 2 there. When I went to my product side and I put that coefficient in front of NH3, which I was trying to tackle the N, but it happened to also touch the H. Well, by me putting the 2 there, that tells me I have 2 hydrogens. Now, when I go ahead and scroll on down to my hydrogen side, okay, I know that I have 6 hydrogens on the left and 6 hydrogens on the right. Are y'all with me so far? All right, good. Let's do another one. And let me tell you, the more you see these problems, the easier it will become, okay? I'm telling you, balancing chemical reactions are not as hard as you may think, so don't overdo it and don't overthink it. Let's go ahead and get into the second one. All right, now we're going to go ahead and get into the next problem. I'm not going to do number 2 just yet. In fact, I'm going to go ahead and do number 4. See, I want to do the easier problems first, and then we're going to work ourselves up to the more challenging problems. I ain't going to call them hard. I'm going to call them what? Challenging. All right, so let's go ahead and do the next one. Number 4, H2 plus O2 giving us what? Water. All right, so here we go. All right, so here we've got, trying to show a separation here. All right, so here we go. We've got hydrogen and oxygen. We got hydrogen and oxygen. All right, so what we're going to do here is count them up. 2 hydrogens on the left, 2 hydrogens on the right. 2 oxygens on the left, 1 oxygen on the right. What's not balanced, guys? Take a look. 2 and 2 says what? They balanced. But when I look at those oxygens, they're not. So I know that between the 2 and the 1, I'm going to get that common multiple, that common denominator. You know that thing y'all talked about when you were in elementary school, when you talked about fractions, making sure that they were equal. 2 and 2 gives me balance on the left, but on the right, I need to figure out what number times 1 is going to give me that 2. And I know it's 2. So guess what I'm going to do? I'm going to put the 2 directly in front of H2O. And just as an FYI, I need to let you guys know, for those of you that have kids or another partner, relationship, whatever, you never ever want to put anybody in between the 2 of you, okay? So if I were to put that 2 directly in front of the oxygen because I wanted the 2 to balance out, you got a disaster waiting to happen. So you got to make sure that you put the 2 in front of the entire compound. That 2 represents a coefficient that's multiplied times the entire formula. So although I put the 2 there to balance out my oxygen, okay, guess what it ended up doing to the hydrogen? It ended up increasing that hydrogen to 4. So sometimes you got to start over and recount, okay? So what you're going to do is say that 2 times 2 gives you that 4, and 2 times that 1, that invisible 1 there for oxygen gives you the 2. Now we're going to mosey on over to the left-hand side, and since our hydrogens are now out of line, out of whack, we need to figure out now what's the common denominator. Well, we know it's 4. Usually it's either when you multiply the 2 numbers to get to get that common denominator, or you can choose the highest number of the pair. Like if you have 2 and 4, the highest number of the pair is 4, so that's your common denominator. If you have 2 and 6, the highest number of the pair is 6. However, if you have 2 and 3, you have to multiply both numbers to get 6. You follow me? All right, so let's go on back over here to the other side. What number times 2 is going to give me 4 so that I can balance out my hydrogens? And that's right, it is that 2. So now you have 2 times 2, that's going to give you your 4 hydrogens. Now, in case you're saying, all right, Professor Ship, you got a lot of stuff going on that screen. Can you go ahead and do that again? Make it look a little fresh and clean? I sure can. Let me show you. All right, so what I'm going to do is make all this stuff disappear. And if you want to go back and watch that part, just, rewind the video, okay? Just rewind it. So let me go ahead and delete, so you can see. All right, so what I'm going to do here is show you the new count, okay? So that way you can see how I am counting everything up right here. All right, so if I look at my hydrogens, I have 2 times 2. That's going to give me the 4 on the left, and guess what? I've got 4 on the right. For my oxygens, I have 2 on the left, and guess what? I've got 2 on the right as well. So we are balanced. Now, one thing you can do is you can add these numbers up. I mean, that's just doing too much. But if you want to, if you add those 2 numbers up, the 4 and the 2, that's going to tell you that you got 6 total atoms on the left. And guess what? 6 total atoms on the right. All right. Let's go ahead and do one more. Oh, and I forgot, before we go any step further, let's go ahead and figure out what type of chemical reaction do we have for number 1. We got 2 elements that form a compound. If you go back to part 1 of the video, and the link will be somewhere above this video. If you go to that video, you will notice that when you have an element plus an element giving you a compound, we call that synthesis. So just think, you and your partner forms one relationship, one union, okay? Number 4, that's also a synthesis reaction. So number 1 and number 4 are the same. Now let's go ahead and do number 3. Okay, number 3. Now number 3 is going to be easy, and let me tell you why. Well, here's the thing. You've got a couple of elements going on in this type of reaction, and what I don't want you to do is to hesitate when doing these problems, and let me tell you why. It is because all of these examples here are designed to give you the idea that balancing equations is nothing but math, okay? I mean, and I say that all the time. I mean, chemistry is nothing but math. That's all this is. It's kind of like pre-algebra. If you're adding the elements on the left side, they should equal to what's on the right side. Okay, so let me go ahead and show you all the next one. You've got sodium chloride, aka salt, plus fluorine reacting together to form sodium fluoride plus chlorine. All right, so here's what we're going to do. We're going to go ahead and put everything down, okay? We're going to count all of our atoms. Make sure that when you tackle them on both sides, that like you don't put fluorine here and chlorine there, because if you do that, you're going to be trying to balance fluorine diagonally and chlorine diagonally. So you don't want to do that. Okay, that just makes life a whole lot difficult, okay? So make sure that you put them side by side in the proper format. So if I start off with sodium on the left at the very top, I need to make sure sodium's on the very top as well over here. All right, and here's fluorine. So 1 sodium, 1 sodium, 1 chlorine, 2 chlorines. Remember, you're letting the subscripts tell you how many you have of each. You've got 2 fluorines on the left and 1 fluorine on the right. So far, my sodiums are balanced, check, but my chlorine and fluorine are not. I've got 1 chlorine on the left, 2 chlorines on the right. This tells me that 2 is the common denominator or the common multiple, whatever you want to call it, okay? So what I need to do here is go ahead and figure out what number times 1 is going to give me 2. And remember that 2 is going to go directly in front of sodium chloride and not in between sodium and chlorine. Oh, and one other thing, you cannot add 2 as a subscript because that changes the entire formula, okay? So anytime you want to balance a chemical reaction, you've got to do what? Form it as a coefficient. So by me putting the 2 in front of sodium chloride, that not only changes chlorine, but it also changes sodium. So now I have 2 sodium atoms and 2 chlorine atoms, okay? Now the other thing that needs to be balanced is fluorine. But guess what? Fluorine is right beside sodium, and they both need that 2. So I'm going to put the 2 right there in front, and guess what? I've now balanced out my sodiums for both sides and my fluorine for both sides. Now, if you want to recount, you can go right ahead and do that. I've got 2, in fact, let me go ahead and do this so you all can see it. I've got 2 sodiums. Oh, that still didn't change the color. Okay, there we go. I've got 2 sodiums on the left, 2 sodiums on the right, 2 chlorines on the left, 2 chlorines on the right, 2 fluorines on the left, and that 2 times that 1 right there will give you 2 fluorines on the right. And if you want, you can add them up. 2 plus 2 plus 2 gives you 6. 2 plus 2 plus 2 gives you 6 on this side. 2, 2, 2, 2, 2, 2. 6 and 6. And guess what? It's balanced. Now, what is this type of chemical reaction? Let's scroll on back because I know it's a lot going on this chemical reaction type. So let's go ahead and look at the clean version of it without all that scribble scrab. And guess what? Number 3, you have a single displacement reaction, or you can call it single replacement, single displacement, tomato, tomato. They both mean the same thing. In other words, you have a single element on the left and a single element on the right. You've got a compound on the left and a compound on the right. So it's compound plus element gives you a compound plus another element. Okay? Let's go ahead and do this last one, number two. And I'm trying to keep these videos very short and to the point so that you don't get over inundated with all of these different examples. Part 3 is coming up because you know some of these chemical reactions are going to get what? Very lengthy. And I'm going to show you how to do those that involve polyatomic ions. Okay, so stay tuned for part 3. So let's go ahead and show you the second one. Okay, here we go. All right, so let's go ahead and talk about this type of chemical reaction before we start balancing this equation. Now, what you notice here is that this particular reaction has a compound on the left side, but then your two elements, or your element and compound, are on the right side. Ladies and gentlemen, this reaction type is called decomposition. In other words, what used to be is no longer. They now have separated or have departed from one another. So let's go ahead and balance this reaction type. You have potassium, chlorine, and oxygen. Potassium, chlorine, and oxygen. You've got one potassium on the left, one potassium on the right, one chlorine on the left, one chlorine on the right. 3 oxygens on the left, but what? You got 2 on the right. So the only element so far that isn't properly balanced are my oxygen atoms. Remember what I told you before, that if you look at the 3 and the 2 and you're trying to get the common denominator, you would want to aim for what? Either the highest number of the pair or multiply them. Because if you say 3, there's not a whole number that you could say 2 times to get 3. Okay? So in other words, let me recap. If I say look at 3 and 6, the highest number between these two numbers is 6. 3 times 2 is going to give you 6. And then 6 times 1 is going to give you 6. If I say 3 and let's say 18, then we know the highest number of the pair is 18. Because 3 times 6 is going to give you 18. However, if I say 3 and let's say through 2, then I have to multiply the 3 and the 2 to get 6. Or if I would have said 3 and 4, let's say I had 3 oxygens on the left and 4 oxygens on the right, then I can't say the highest number between those two is 4. I mean, that's true, but in terms of chemically trying to balance them, I can't do that. I have to figure out a number that's common between both of them. And in this case, what's 3 times 4? 12, okay? So let's go ahead and go back over here. I know that the common number that's between 3 and 2 is 6. So now let's go ahead and start on the left-hand side. What number times 3 is going to give you 6? And if you said 2, you are right. So that's going to change my potassium and my chlorine. And that's going to give me my 6 oxygens also. Guess what else I need to do over here? Since I've tackled the 2 for potassium and the 2 for chlorine, and they both need 2, I'm going to put a 2 in front. And guess what? That takes care of potassium and chlorine. Now let's go ahead and hit that oxygen. What number times 2 is going to give me 6? And if you said 3, you are correct. Because 3 times 2 is going to give you 6. Now, if you want to go ahead and recount to make sure everything is good, let's do it. 2 potassiums on the left, 2 potassiums on the right. 2 chlorines, because remember, 2 times that Cl is 2. 2 times that chlorine right there is 2. 2 times your 3 for your oxygen is 6. 3 times 2 right there for that oxygen is also 6. And if you want to do the little extra work, 6 plus 2 plus 2 is 10. 6 plus 2 plus 2 is 10. You are now complete. All right, I got this video in under 20 minutes. Woohoo! Have a good one. And stay tuned for part 3 when we get into those polyatomic ions, and they're way longer in terms of the length of the reaction. See ya.